Space is often imagined as silent and empty, a peaceful darkness between the stars. But in reality, space is filled with invisible energy. One of the most powerful and constant forces in the cosmos is radiation. Cosmic radiation is a storm of high-energy particles traveling through space at nearly the speed of light. Some of these particles come from the sun, carried outward by solar wind. Others come from distant supernova explosions, neutron stars, and violent events far beyond our galaxy. These particles move unseen, passing through the universe, and sometimes through our own bodies without us ever noticing. Earth is protected by its atmosphere and magnetic field, which act like a shield, absorbing most of this radiation before it reaches the surface. Without this protection, life as we know it could not survive. Cosmic radiation reminds us that space is not a gentle environment. It is an ocean of energy, filled with forces that shape planets, stars, and the possibility of life. The story of cosmic radiation begins with the realization that the universe is not made only of light. It is also filled with particles, fragments of atoms moving at incredible speeds. These particles are known as cosmic rays. They include protons, electrons, and heavier atomic nuclei, accelerated by some of the most extreme processes in the cosmos. When a massive star explodes as a supernova, shock waves race outward through space, accelerating particles to enormous energies. When neutron stars spin with powerful magnetic fields, they can fling particles into galaxies like cosmic cannons. Even the environments around black holes can accelerate matter to near light speed, creating jets that shoot across interstellar space. These high-energy particles travel for thousands or even millions of years, crossing the galaxy until they encounter something in their path. When cosmic rays strike Earth's atmosphere, they collide with molecules and create cascades of secondary particles, showers of radiation that spread through the sky. Most of these particles never reach the ground, but some do, reminding us that even on Earth, we are not completely isolated from the cosmic environment. The atmosphere is not only the air we breathe. It is a protective blanket that shields life from the universe's constant bombardment. The magnetic field also plays a crucial role. It deflects charged particles, guiding many of them toward the polar regions where they create auroras, shimmering curtains of light that dance across the night sky. Auroras are beautiful, but they are also evidence of radiation interacting with Earth's defenses. They reveal that space is filled with invisible storms. Cosmic radiation is not only a distant phenomenon, it is something that affects every planet, every spacecraft, and every future journey into deep space. Beyond Earth's protective atmosphere, radiation becomes one of the greatest challenges for exploration. Astronauts aboard the International Space Station already experience significantly higher radiation levels than people on the ground. They are still partly shielded by Earth's magnetic field, but not completely. Over long missions, radiation exposure accumulates, increasing health risks. This is why deep space travel is so difficult. A journey to Mars, for example, would expose astronauts to cosmic rays for months or even years. These particles can penetrate spacecraft walls, damaging DNA, increasing cancer risk, and affecting the nervous system. Radiation is invisible, silent, and relentless. It cannot be avoided simply by wearing protective clothing. It requires shielding, careful mission planning, and new technologies that scientists are still developing. Cosmic radiation also affects the machines we send into space. High-energy particles can disrupt electronics, flip bits in computer memory, and damage sensitive instruments. Spacecraft must be hardened against radiation, and engineers must design systems that can survive the harsh environment. Even satellites orbiting Earth can be affected during solar storms, when bursts of radiation from the sun intensify. Solar flares and coronal mass ejections can send waves of energetic particles toward Earth, disturbing communication systems and power grids. These events remind us that radiation is not only a distant cosmic force, it is part of the space weather that shapes our modern technological world. Radiation also plays a role in shaping the universe itself. In interstellar space, cosmic rays interact with gas clouds, triggering chemical reactions that produce complex molecules. These molecules may become part of future planets, and even the building blocks of life. Radiation can influence star formation by heating clouds and affecting how matter collapses under gravity. In this way, cosmic radiation is not only destructive, it is also creative, shaping the chemistry of the galaxy. On the largest scale, radiation carries information about the origin of the universe. The cosmic microwave background is a faint glow filling all of space, the afterglow of the Big Bang itself. It is radiation that has traveled for nearly 14 billion years, reaching us as a whisper from the beginning of time. By studying this background, scientists learn about the early universe, the formation of galaxies, and the evolution of cosmic structure. Radiation is therefore both a danger and a messenger. It reveals events we could never witness directly, such as supernova explosions in distant galaxies or the energetic processes near black holes. Cosmic rays that reach Earth are like particles from deep space delivering clues about the most extreme environments in existence. The invisible storms of radiation are part of the universe's hidden architecture. Space is not empty. It is alive with energy, constantly moving, constantly interacting, shaping the destiny of worlds. Cosmic radiation also forces us to confront how fragile life is in the universe. On Earth, we live beneath layers of protection, the atmosphere, the magnetic field, and the stability of our planet's environment. These shields have allowed life to flourish for billions of years. But beyond Earth, the universe is far less forgiving. Radiation is one of the fundamental reasons why life may be rare or difficult in many regions of space. A planet without a strong magnetic field or thick atmosphere may be exposed to constant bombardment, stripping away its air and water over time. Mars, for example, once had liquid water on its surface, but it lost much of its atmosphere, leaving it vulnerable to radiation. This illustrates how cosmic forces can shape the fate of worlds. Radiation does not only affect humans, it affects the possibility of life itself. Yet radiation is also part of the story of existence. Without the violent deaths of stars, without supernovae accelerating particles and spreading heavy elements, the universe would lack the materials needed for planets and biology. Cosmic radiation is connected to the same stellar processes that created carbon, oxygen, and iron. In this way, the universe is both harsh and generative. The same events that produce destructive radiation also produce the building blocks of life. Radiation also reminds us that the cosmos is interconnected. A supernova explosion in one region of the galaxy can send particles traveling for thousands of years, eventually reaching distant systems. The universe is not isolated pockets of matter. It is a vast network of interactions, where energy travels across unimaginable distances. Every planet exists within this energetic web. Even now, as you listen to these words, Particles from distant explosions are passing through space around you, silent evidence of cosmic events far beyond human experience. Looking forward, understanding radiation will be essential for humanity's future in space. If humans ever establish settlements on the Moon or Mars, protection from cosmic rays will be one of the greatest engineering challenges. Underground habitats, advanced shielding materials, and perhaps even artificial magnetic fields may be required. The dream of becoming an interplanetary species depends not only on rockets and technology, but on learning how to survive in an environment filled with invisible storms. Radiation is one of the universe's most constant realities. It is present in the glow of the sun, in the remnants of supernovae, in the afterglow of the Big Bang, and in the energetic particles that race through the galaxy. It is both a threat and a source of knowledge. By studying cosmic radiation, we learn about the most extreme places in the universe and about the deep history of the cosmos itself. Space may appear dark and empty, but it is alive with energy, filled with forces that shape galaxies, influence life, and carry messages from the distant past. The invisible storms of cosmic radiation remind us that the universe is not silent. It is dynamic, powerful, and endlessly mysterious, waiting to be understood.